Tanya. Uh, this question, there was one part that I didn't cover. I just saw that. It's what's the probability, was question probability of type 1 error, and that would equal alpha. Whatever alpha provided in the question, and it's 5%. So now we can do question 3. That's the two-sample independent. So in 2007, music educator undertook a study of achievement of students in 2 classes. One class was located in Halifax, the other in Vancouver. The students in Halifax were taught using a new method, while the students in Vancouver were used a control group. Here is the Minitab. So the Minitab is provided. And everything, the p-value and everything. Now they tell you state in everyday language what the p-value tells us about the difference between. I mean, basically you need to do it a complete hypothesis to be able to do it. Okay. P-value only gives you indication of conclusion hypothesis. Now, we're trying to see difference. We're testing for difference. So, H0, HA. Mu1 minus mu2 equals 0 versus mu1, mu2 not equal 0. This means they're not different. This means they're different. And the not equal indication that you're doing this problem as two-tailed. To define the parameter, let mu1 be population mean. And what's the mean in the question? It's 2 classes located in Halifax. The students were taught using a new method and control. Here is the Minitab. Music education undertook a study of achievement. Mean, I think, doesn't indicate very well what the mean is, but I think it's the mean of achievement level or achievement score. Mean of achievement level or value for the population of all. And the first group would be the group Halifax. For all students or music students in Halifax. To define mu2 would be the same thing for all music in Vancouver. So we state the hypothesis. Now we look at the p-value. If you read the question, there was no alpha given. So to do the p-value, since no alpha given, we have to, or we can only do it based on strengths. There are 5 levels for the strengths. It was given, it's provided in the exam Now, it's provided in the sections of your textbook. Now, if you go to that, I'll send it to you when I send you the copy of the test. I'll send the strengths level, what I'm talking about. You'll see that your p-value is actually more than 10%, because your p-value provided in Minitab is 14.3. It's more than the 10%. We have large p-value, very weak evidence for HA. We have very weak evidence to prove HA. So we say in English, again, we didn't talk about the assumptions here, since we didn't talk about the assumptions, and there was no mention of the assumptions being met, so we go, if assumptions hold, and we have to use the strengths language. We have a large p-value, very weak evidence for HA. But instead of HA, for that population mean of achievement value for population of all music students in Halifax and Vancouver is different. So there is no proof that the mean of the group 1 and the mean of group 2 different. So there are we have weak evidence to prove, or we cannot prove basically, that the population mean of achievement value for the population of all music students in both cities different. No proof that they're different. Okay, now the part C in the question, no, part B still. So first of all, we proved, remember, from the hypothesis, we proved that they're not different, meaning that they're actually the same. Anytime you prove not different, you're basically proving that they could be the same. Okay. Give 90% confidence interval for the difference and interpret what it means. Okay. Well, in Minitab, the confidence interval is provided. But again, we're gonna still do it. So you need in the question, you just need to put it down, but I still want you to be familiar of how it's done. For this chapter, it's average group 1 minus average group 2 plus or minus T star standard deviation 1 squared over N1 standard deviation 2 over N2. We get T star first. To do it, we need degrees of freedom. Now, for the degrees freedom, you look at the Minitab, the degrees freedom could be provided. If it's provided in Minitab, use it, because there is a very special way of calculating it. If not, do it this way. It's only for this chapter that it's a little bit different. It's N1 plus N2 minus 2. So N1 is 120, and 68 minus 2. So your degree freedom is 186. And it's at 95% confidence interval. You go to the T table. This is the one I'm using. You'll see that there is no degree freedom 186, so the closest I have is 100, and it's 95. 95 and 100 would be 1984. 1984. So when we calculate this, we might not get the same answer. It could be close because Minitab uses the exact degree of freedom. So his number is not going to be necessarily 1984, but if you're asked to do it in the exam, using the 1984 is good. So from Minitab, so again, our answer would be a little bit off. In Minitab, the average Group 1 Halifax is 1387. For Vancouver is 1275. Your T-star is 1984. The first standard deviation is 22 squared over the first sample. And the second standard deviation is 0.4 squared over the second sample, 68. So we do this part first, 1387 minus 1275. Just this part is 112, plus or minus, now we do this part. 1.984 times square root of 0.22 squared over 120, 0.4 squared over 68. Now this number is 0.4. So now you open brackets, you add them. This gives you 216, and when you minus them, it gives you there's something strange. Let me just double check one thing in the calculation, because the confidence interval they provided is, if we assume that it's correct, it must be close to the answer. You do it the long way. So I'm doing it the long way. So 1387, 1275. This is the first number. Let me do this one. 1984 times square root of 0.22 squared over the first sample, 0.4 squared over second sample. So the answer I get doesn't match what they have. probably the reason is this number. Again, this number is a little bit different because they use a certain degree of freedom and they use a certain number, so it's hard to do it if you don't have the for this chapter. But again, if you're asked to do it, this is the formula that we go by, and you would have all the information, and T star, they would give you degree of freedom, or you would use it. But the thing is, since these are large samples, degree freedom could be way different. So in this case, if it's a large sample, they would give it to you. Okay, so again, all you needed to do is to provide the confidence interval. This is the confidence interval, so, and then they want you to interpret what it means. And does it show that they're different? Because remember, when we did it using hypothesis, we proved that it's not different. Okay, so we say, since there's no talk about the assumption, so if assumptions hold, we are, and whatever the percentage is, 95% confident that population mean achievement value that the difference in population mean achievement value is between this number and this number for the population of all music students in Halifax and the population of all music students in Vancouver. Okay, now we talked about the how you explain the confidence interval. Now, is this consistent with the hypothesis that we did earlier? To actually be able to see if we have consistency, anytime you do confidence interval for difference, whether it's paired sample or two sample independent, you'll end up with one of three possibilities. It could be that the first number negative, the second number negative, positive, or like you have negative, positive. If you end up with negative, you say not different, since, oh no, you say different since 0 is not within confidence interval, and 2 negative means group 2 is higher. Positive also means different. 0 is not within. Group 1 is higher. So basically, if the difference between two negative numbers, you're not going to go through the 0, so they must be different. Between two positive numbers, you're not going to go through the 0, so they must be different. But negative, positive, and that's the case you have, they're not different. They actually could equal each other. Reason? Since 0 is within confidence interval. So in your case, the groups are not different. They're actually possible. It's possible for them to be the same since 0 is within. And in this case, it's consistent with hypothesis. They both prove the same thing. Then in part C, they tell you we used an unpooled two-sample T procedure. Could have we actually pooled the information? It's the idea of can you pool versus can you not pool. This is what we go by. If you take S large over S small, and that's less than 2, then you have equal variances. Yes, we can pool information or pool data. If your S large over S small is more than 2, do not have equal variances. Cannot pool information or data. So we go to Minitab. The two standard deviations are 0.22 and 0.4. So the large one is 0.4. You divide it by 0.22. That gives you 1.811. That's less than or equal to. Then yes, we have equal variances. Yes, we can pool the information. I'm also going to talk about the assumptions for this chapter. Independence first. Did they mention anywhere in the question that the sample was selected randomly? No, not met. Samples of music students were not selected randomly. We discuss normal probability condition. Again, there is no mention in the question whether you have normal distribution or not, and no histogram, no probability, normal probability plot, nothing is given, cannot assess. So you need to check sample size. Sample size assumption must be checked. Now sample size assumption, for the first sample it's 120, for the second sample is 68. Both of them is way more than 40. So data can be weird with gaps and outliers, and still the condition met. So condition is met. Now, the new assumption for this chapter is the independent group assumption. Do we have two separate groups? You say yes, met. Two separate or independent groups, one in Halifax and one in Vancouver. So yeah, they're basically, obviously they're separate. One in one city, one in another city, so they're totally separate. So this condition of having independent groups satisfied. Again, two things I want to mention. The way I'm explaining this is the standard way of what they do in this course. So I'm hoping that this semester, because it's all online and stuff, that they haven't changed a lot. I don't think Nelson will change a lot. Now the other thing is also look at the assignment for this chapter and the previous one, like the paired and the independent. The questions were good. This is a good question, but it's better to see more questions. And if you want a link for more videos for these two assignments, and I believe there were assignments maybe 2 and 3 or 3 and 4, I can send it to you. Now the only thing left to go over is the idea of chi-square, goodness of pet versus independence. So I'll do this in the next video.